Right, hello, this is the second part. Well, not the second part really. We did the chain rule, the quotient rule, the bracket rule, and the Fireworks rule. Well, I haven't said that twice. What we're going to be doing in this video is we're going to be talking a little bit about differentiating trigonometric functions. Okay, so what does differentiating trigonometric functions mean? Well, it's your sine, cos, tan, and then a few more, such as cosec, sec, and cot x. Now, they all may sound stupid, and you may go, why have you left them rules on the board? Well, I'm going to rub them out. If you want to just go back a few minutes, if you haven't got them down, then you should do. I would recommend doing that, purely because we're actually going to be using them. More the last two than the first two, and more the third one than the last one. So generally it's going to be the third one. I could have just said that, but you never know. This is maths, I like to confuse you. Right, so I'm going to draw now on the board. I'm going to split the board up, and I'm going to say we're going to do it across, so we're going to do it lengthways. So I'll put the function of y going along that way. I'm going to split it up. I'm just going to rub this out, but if you want to do some revision notes on this video, this is a good thing to do. Function of y, and then I'll put the dy over dx of that function. So you can try and set it out like you, obviously you're WE to the mine. And the first function of y, so this would be y equals, but I'm not going to do y equals, I'll just put the function. So if it's 3x plus 2, I'll just put 3x plus 2. Obviously we're not going to put that. There's the sine x, which you should be familiar with, your cos x, and your tan x. All seems fairly understandable. So they're the three that I'm going to focus on. Obviously I will differentiate cos x, cosec x, and sec x, and I'll explain how we do that, but you need to understand what they are first, and you need to understand the differentials of these, which is a bit more important. Okay? So, if you haven't completely messed this up, so by messing it up I mean just copying straight of that. So what we have is we have cos x, and inside, so sort of our three main sections of these three, and it'll have 6 subsections. So I'll have 2 subsections for tan x, 2 subsections for cos x, so it'll be cos of x and cos of 2x. They're the two that I'm going to differentiate for cos x. So I just put cos x and then in brackets 2x, and I'll give that as another, because we need to know how to differentiate. Then I'm just going to go, so differential of sine x, 2x. So hopefully this makes sense. And then split tan x up into 2x. So when I put 2x, that just means the left one, so if it's sine x and then the bracket, and then the next section is 2x, that's sine of 2x instead of x. Hopefully that makes some kind of sense. Or you can draw this table tightly differently. So, sine x, so if we differentiate sine x, we get cos x. How do we know that? Well, if you do the sine curve, and you do the differential of the sine curve, it's the gradient at that point, it becomes sort of a double helix sort of thing. And if you look at what the intersections are, you'll find it's actually the cos x curve. You can prove that to yourself if you want by looking at the two curves and sort of placing them on top of each other, if that makes any sense. So I'm just going to go through the main one. So cos x is minus sine x, and I'm going to talk about the integrals of these as well. And then the differential of tan x is sec squared x. That's the funny one. So I'm not going to put the differential of tan 2x, I don't think they'd ask that. Now what's the differential of sine of 2x? Now it's still cos x, but it's 2 cos 2x. And that's the same for cos of 2x. It's the same function, so it's minus sine x, but instead of minus just sine x, it's minus 2 sine 2x. And that's the differential of them. Now, over here, I'm going to rub out tan x. And what I'm going to do over here is we're going to actually integrate these two. And the reason I'm doing this here in this differential video is because it's the opposite. Just as the differential going, you're timesing it by that and then reducing it by 1, the integral is increasing it by 1 and dividing it by that power. So, same as we did the opposite for just standard functions of x, we're going to do the opposite for basic trigonometric functions. It's the same thing we're doing, just to a different function. So, the sine x will, so you know where cos x becomes negative sine x, this is going to become positive sine x. And the inverse of, so the integral of sine x is going to be negative cos x. Okay, so this isn't confusing at all. So if you remember the differential of sine x is cos x and cos x is the funny one that goes negative, the integral of them two will be the opposite of that. And that'll be the same for the 2x's. So sine of 2x, we times that by 2x. What we're actually going to do is we're going to divide it by 2x. So it will become sine 2x over 2. Okay? So sine 2x is, the integral of that is sine x over 2. Alright, so if we do the integral, that's why I left another part on my page here. So if we do the integral of the top parts, so the inverse of sine x is negative cos x, and the inverse of cos x, which would normally go negative, but this time it goes positive because we're integrating it, positive sine x, and the integral of sine x, sine 2x is negative cos x over 2, or half of cos x, and negative, and the inverse of cos x is cos 2x, sorry, is positive sine over sine x over 2. And obviously we would have a and b limits there. Okay, so that's the differential functions of sine, cos, and tan. And that's the integral of them as well. Okay, so what I'm going to do over here is I'm going to leave this on the board and I'm going to focus on this section of the board here. Now at the start of this video I did mention about I did mention about cos x, cosec x and sec x. So what do they all mean? Okay, now if you remember, we had this is completely unrelated. You can completely ignore this little bit I'm about to say here, if it confuses you. If you remember, cos is cosine, okay? We have cos x there. So you could think of that as cosine x, would it? It sort of is, really, actually. And sine x is the sine rule thing, okay? So when we do cosec x, what we're actually doing is the opposite, just like we did the opposite of the differential and integral. We're doing, it's not, so cos, it's 1 over, so these cot x, sec x, and, sorry, the cot x, oh my god, I can't believe I'm even confusing myself here. So cot x, cosec x, and sec x are 1 over the other function. So one of them is 1 over sine x, 1 over cos x, and the other one's 1 over tan x, or cos x over sine x, which is actually tan x, but we leave that as the same thing, weirdly. Okay, so back to my original point of the cosine stuff. Okay, so cos x, you'd expect that to be 1 over cos x is cosec x. Well, it's actually not, it's actually sec x. That's the bit that I was trying to hint at. So, cosec x is actually 1 over sine x. And sec x, as you could probably guess, is 1 over cos x. And we said cot x is, you could either say it's 1 over tan x or cos x over sine x. If I've got that the right way around, one sec. So let me make sure I've got that the right way around. Yep, that's the right way around. So they're all correct. Okay, so I'm just going to split these up here, because what I'm going to do with these is I'm going to differentiate these ones as well. So remember we said cosec x, so if I move all this up, so if you remember cosec x was actually 1 over sine x. So everything is the opposite of what you think. Sec x is 1 over cosine of x, or cos x, and we said cot x equals 1 over tan x, or cos x over sin x, which is the opposite of tan x, if you remember. So because tan x is sin x over cos x, and if you flip that round, that's 1 over tan x, which is the same as cot x. That's why we can put that there. Didn't explain it very well. Okay, so the differentials of these are going to be slightly different. Now, I'm not going to write this little bit of information down on each one, but I think if you have a bit of space on your board or a piece of paper, I think it's quite key too. Okay, so what are we talking about when we say 1 over sine x? Well, you should know, anything to the power of minus 1 is 1 over that. So that's what they are, sine of x to the minus 1. And then the 1 over cosine x is cosine x to the minus 1, or cos x to the minus 1. And cot x is, as that's 1 over tan x, it's tan x to the minus 1. Okay, so that's what we need to work with. And we can apply our rules of your product rule, your product rule, your bracket rule, your chain rule, and then your quotient rule. Not in the right order that I did them, but never mind. Okay, so as that is 1 over sine x to the minus 1, we use our chain rule. Oh, damn it. Sorry. And then what we do is we get minus sine x to the minus 2. If you this is key. If you don't get this, it's no pressure, because they do generally give you this in the exam, the workings out for this. But no, the answer, sorry, that's all you're really interested in. And you times your minus sine x to the minus 2 by cos x. That's right. Sorry, even I'm just trying to I'm keeping this because I don't want to make a mistake. And then you simplify that, so that's 1 over sine squared x, and that's cos x over, oh wait, sorry, yeah. So it's 1 over sine x, and then you put that sine x over the top, so it's 1 over sine x, and that should be 1 over sine x squared, but because we're putting another sine x up here on this side of the equation, so it's sine x, sorry, yeah, it's cos x over sine x. Because remember, when you times a fraction, you times top by bottom. So, bottoms and top. So sine, this becomes 1 times cos x, which is cos x, and sine x over sine x, which is sine squared x, but it's minus 2, so it's minus 2 sine squared x. And obviously, if we simplify this, so 1 over sine x is cosec x, so that's cosec x times cot x. Because remember, cot x down here, this function here is that function there, so that's cot x. Okay, so that's the first part of that. Done. Right, so sec x is 1 over cosine x, so that's cosine x to the minus 1. So we don't need to write that again. Do the same thing, so do the same thing as this, but the opposite. Instead of putting sine x there, we put cos x to the minus 2, and we times that by positive sine x on its own, and we just do the same method we did for up here, but we do it for cos x on the bottom instead. So that's 1 over cos x times sine x over cos x, and that therefore sine x over cos x is tan x, and 1 over cos x is sec x, so sec x times tan x. That is the differential. Okay? So hopefully you get that. Hopefully this is starting to make sense. So this cot x is slightly different, and now because cot x is cos x over sine x, we actually don't use the chain rule. We actually use the only rule that had a fraction in it, which is obviously the quotient rule. So that's what we do. So you can imagine the cos x and sine x, they're just functions of x, like y equals sine x or y equals cos x. They are functions of x. You could write them in a graph, you might see them in a graph as y equals fx equals sine x. That's the same as saying y equals sine x. So we do the same thing. So if you cast your mind back to the rules, we just simply do v times the differential of u over differential of x, take away the u times the differential of v over the differential of x over v squared. So that gets us sine x times minus sine x. Oh, sorry. And we're taking that away from cos x plus cos x times positive cos x, sorry. And we're doing that all over v squared, so sine x squared. So that's sine squared x. And then obviously this all cancels out to, because sine squared x plus cos squared x, which is a trigonometric identity, equals 1. You should know that from C2. And obviously it's taken away instead of adding, so it's 1 over sine squared x. So hopefully that makes some sort of sense. Okay, so they're the main parts of the exercise there. I've gone through a few of the rules. I've not gone into too much detail about them last three there, and that's because they're not really required on our spec to say that you have to know them, sort of. So hopefully that makes some sense. Well done for sticking through it. That last bit especially was quite hard, but hopefully that makes some kind of sense. So if you want to take a picture of that or copy that down, because that is quite a key bit of information on that board. So hopefully that's been a bit of a welcome back to maths. It's definitely one of the hardest things I think we've done. Definitely a lot harder than your trigonometry in C2. You're really stepping up a level here. Hopefully that's been some kind of use to you, and we'll see you in the next video.